Hello, how's it going? So I want to have a look at DirectX 12. Well, because I'm interested in it. Today, the goal will pretty much be to set up our basic project and select an adapter, basically. So I'm starting here with my Direct 2D project that I was working on in my Windows programming playlist. So if any of this Windows concepts are strange, check out my Windows programming playlist. It's not that big, but I'm going to do a few things to set everything up first up. So we're going to need the Direct 3D 12 headers and things. We should have access to those already with our Windows SDK. So if we just go include Direct 3D 12, yeah, I've got that, no problem. But there are a few things I'm going to do straight up. One of them is to go to my project, properties, linker, input, and see in here I've got this Direct 2D 1 lib that I'm depending on. I'm going to get rid of that and specify another library. I just want to do all the dull stuff, get that out of the way first up, and then we're going to get to the fun. So I shouldn't say that, all my stuff is fun. So I'm going to include the DirectX or Direct 3D 12 library, and there's two more that I'm going to include. DXGUID for getting global IDs of DirectX objects, and this DXGI library. So those are all declared. Okay, good. But I'm also going to grab some DirectX extension headers as well. These just have some useful features. So the way we can grab these is we can just go online. Here we go here, and I've just searched for D3DX12 headers, and there's this GitHub repo, and it's this DirectX headers repo, which is really useful. So we can clone this, download this stuff, and then it's this include folder, which is really good. So what I'm going to do is I'm just quickly going to, I could git clone it, but I'm just going to download zip. I'm a little lazy today. Let's go ahead and extract those, and then we've got this include, and I'm just going to grab all of that. Then I'll go back to my project, and I'll make a new folder called dependencies, and inside there I'm going to paste those headers. Then I can go back to my project, properties, and up to VC++ directories, and then here where I've got include directories, I can just pop in there, and I'll use the old trusty macro, project directory, dependencies. Fingers crossed, please work. And we can test that this is working by, so for instance, if I were to go include, yeah, we've got DirectX. That's the folder that I posted in there. And then we can get that DirectX 3D. Cool. Okay, so with all of that out of the way, let's get in and start working on our project. So I'm just going to get rid of all that. Bam. Okay, so this is my main file. In my source, I'm going to include some other things. So I'm going to have a folder called renderer, engine, whatever you want to call it. And then inside there, I'm going to have a few things. I'm going to have, I'll call it renderer. So I have a, whoops, okay, oh my goodness, okay. So we'll have our renderer module. Then I'm going to include some code for working with adapters. So I'll go ahead and call this adapter. And then in addition to that, I'm going to have logging code. So I'm actually going to go from the bottom up. So I'll start with the logger code, and then I'll go back to the other code. So for the logger, this will be pretty similar to what I've got already in my Vulkan stuff. So I'm actually going to copy paste a lot of this because it's the same stuff. So the basic idea is my logger is a class and it's a singleton, it's a static class. So at any point we can get access to it and we can modify it. So we can check these things, whether it is currently enabled, we can set its mode so that dynamically we can tell this thing to print out messages or not. And then when it gets a message to print something out, it can either print that thing out or just ignore it. So this is what we've got so far. Link in the description, but hopefully this stuff is self-explanatory. Really, the logger is not the main point of this video, but let's go ahead and make it anyway. So in this unit of code, we've got that static pointer, which we refer to, and here we can set the mode, either enable printing or disable it. We can also check whether the logger is currently enabled. We can grab the static pointer to this instance, just like that. I know I'm running through this. Okay, so how about printing stuff out? So what we could do, I'm just going to mock this up for now. Usually we would do something like this. So we'd have a string message. We would then test if we're not enabled, then do nothing, right? Just stop. But then continue if we are enabled, and if we are enabled, then print out that message. Something like that. Now, I'm not going to go through with this. The issue is that this is a Windows program. It's not a terminal program. So we don't have this debug terminal that we can print to. However, what we have instead, if we look down here, is we've got this terminal thing here, and we can print to that. It's just slightly different. So what we can do instead is we can take a Windows wide string, so a long pointer character wide string. Thanks, Microsoft. Really great naming convention. But then what I want to do is there's a function which I can use, which will print that string out to the terminal down the bottom. In order to do that, I'll need to include the debug API header, and the macro that I use is I think it's output debug string, and we can then put in that message. Because we're in Unicode, we're using wide strings, so we can see that this is defined as the string wide version. There we have it. So I'll leave that there for now. We'll revisit this later when we have a DirectX object to log out. But let me go to the renderer. So the renderer is going to be very similar to what we've got here, this main window. So I'm going to grab all of this, stick it over, and of course I'll go back to main and get rid of that main window. Also going to get rid of the safe release. I'm not going to use that. And while I'm at it, cool. So as for the class, I'm not going to worry about this stuff just yet. Not even going to worry about this. So my use case here is I'm going to have, let me just put some of this back in. I'm going to have a window that I'll work with, and that will be initialized at the point where all the main resources are created. So at this point, we'll take in a window object, create the resources or attempt to, and then return a result. I will have a destroy resources function. Why not? But I'm not going to need any of this stuff. So I'll flesh these out in a second, but I'll go back to my main program and get this correct. So we're gonna have, I won't worry about that. All right, so we've got the main window. Oh yeah, let's change the class name. A lot of back and forth, cool. So we'll have a renderer object which gets passed in to the window. So that's all bound together. So this is all looking fine. Then on the other end in the main loop, we'll then have this renderer and how to actually initialize the results at this resources at this point. So we'll create resources, and at this point, whoops, we'll pass in the window, it'll do its thing. Okay, yep. So in the case of destroying the window, we destroy the resources and that's it. And these other events I'm not handling yet, so not super exciting, but it's all, the infrastructure's set up. So in terms of what we'll actually be doing, well, I'll go over to the adapter header, and now I'm going to put in a few things. So one thing I'm going to need is the Windows Runtime Library. That's WRL. And the reason I'm using the Windows Runtime Library is to get what's called COM pointers. Now a COM pointer is a smart pointer, basically. The idea, if you look back to my Windows programming video, at the end of that, I was doing some stuff with like safe releasing pointers, and we can manually manage our pointers in different ways, but also these pointer object things have constructors and destructors, and a smart pointer uses those constructors and destructors to automatically manage reference counts and work out when pointers should be freed. So the benefit of using these COM pointers is we don't have to worry about freeing them. That's done automatically for us, which is really useful. But just to shorten things, I'm going to use the namespace Microsoft WRL, because otherwise we'd have something like Microsoft WRL COM pointer, and if I can't say WRL, how am I going to say Microsoft WRL COM pointer? So no way. We're shortening it. All right, cool. So the idea is we're going to have some function which returns a handle to a result. That function is called getAdapter, and it will take in a reference to a COM pointer which will be populated with the adapter. So I have a COM pointer to a adapter. Now the adapter, let me see if I can find which header this is in. I think it's in, actually, what am I thinking? I'll just search. So what I'm looking for is an interface to a DirectX GI adapter 1. And it tells me that this is in dxgi.h. Okay, by the way, this is a funny thing. The way DirectX works is these objects are all interfaces. So we have some interface, and interfaces can be pretty easily cast between versions. Here we've got this DXGI header. It has an adapter 1, and then if we look in, there's these variants. DXGI 1, 2, DXGI, all of this stuff, and we can sort of click through and say, okay, well, there's nothing here. What's up here? There's an adapter 2, for instance, so we can say, oh, okay, cool. What's the difference between an adapter 2 and an adapter 1? And it says here that the adapter 2 represents a display subsystem which includes one or more GPUs, all this stuff. Fine, that's fine. But each of these inherits from the previous version. So this is like a way of extending for future versions of a DirectX component. But anyway, point is we need the DXGI header. So we'll go ahead and include DXGI. And as you can see, we've got all these versions here I'm just going to go DXGI. It's an IDGX adapter 1. Be a reference to that called chosen adapter. Okay, so I won't worry about the implementation just yet. I'll go back to my renderer and I will deal with that. So inside the renderer class, we will have a COM pointer to that adapter. And of course, in order to do that, we'll need the DXGI header. Oh yeah, and we're going to need COM pointers. Cool. Okay, so I'm just going to go over to my source code. Oh, renderer. Oh my goodness, that's a new one. I need to have a lie down or something. I don't know. So back to business. So the first thing I'm going to do is I'm going to capture the handle to the window, and then I'm going to initialize my logger. So I should go ahead and include the logger header. Cool. And I'm just doing that so that I can enable it. So now it's going to be squawking out messages for me. Okay, cool. So I'm going to go ahead and get the adapter. Cool, so I'll go ahead and do the destruction code as well. So the funny thing about this is that because everything's being managed with COM pointers, we don't need to worry about this stuff, and as a matter of fact it'll cause errors if we do. Not sure if it should cause errors, but it does. So this is complaining because I've given a string constant, but it wants a long constant, a wide string, so we can just put an L out front. There we have it. Okay, so far so good. Now I'm going to why do I call that engine? Now I'm going to dig into selecting the adapter. Okay, so what I'm going to do at the start, of course, is grab the logger. In these early steps, I think it's important to print some stuff out so we at least have some sort of... So I'm going to use a factory to look at the available adapters, a DirectX factory. So I'll go ahead, I'll have a COM pointer to a factory, and it needs to be a factory 1 for the reason that I want to be able to look at the adapters. So we've got this DirectX factory thing. Oh, it's got enumerate adapters. Let me try this. Let me see what happens. Let's see what happens. And I'm also going to have some creation flags to specify optionally whether I want to create a debug factory or not. So in Vulkan we have validation layers, but in DirectX we can create debug factories. So what I'm going to do is I'm just going to check if the program is running in debug mode, and if it is, I can go ahead and set DXGI. So what I want to do is I want to go factory. I want to set these creation flags, and I want to put in this constant here, create factory debug. But clearly that's not present in the original DXGI header. So what I can do is I can just pop in and look through the factory stuff, and I think it's just from memory. This isn't a lot of fun, but I think so. There's this create factory 2 variant, which is defined in the 1.3 header, which takes in a flag, and I'm guessing that that is the version where that flag is defined. So I can back here and then include 0.3, and then that's defined, and we're all good. So what I'll do now is I'll go ahead and create that factory, and this factory creation will return a handle, so we can handle to a result, so we can query that directly. So we'll go create DXGI factory, and it's factory 2, which has the flag. So we'll go in factory creation flags, and now there's a few things here. So these like creation functions, they return basically pointers of some sort, handles, but they need to take in a globally unique identifier to the object which is being created. And this ensures that we're not double creating something, or it's simply a requirement of the component object model. Which, by the way, if you want to read more about this, in the official code that I'm giving for this, I've got links to resources, but we can look this up. We can go com coding practices, and there's some info in here about sort of universal identifiers. This is interface ID, as well as safe release stuff and com smart pointers. Like, all the info's there, it's all linked. In terms of what we're doing right now, like I said, there's this IID, and what this does is it basically takes in the object, and we can see here it's essentially getting the universal ID of that object. But anyway, so what we're doing is this will go ahead and create the object, and then we can print some stuff out if we fail. So for a return, just 0 is success and anything non-zero is a failure, so that'll work just fine. So if we get to this point, our factory is created and it's ready to go. We can then start using that factory to scan through all of the adapters which are available on the system and inspect them. So what I'll have is I'll have a com pointer to the adapter, and this is the temporary object that we're looking at. As we go through one by one, we'll be using that to set the value of the chosen adapter. And the thing that I'm really interested in is the amount of dedicated VRAM. For this case, I'm just using it as a heuristic to determine the best adapter. So what I'm going to do is I'm going to start scanning through. So I'll have this for loop, and the condition that I'm looking for is enumerate the adapters, adapter I, put it into that adapter object, and the failure that I'm looking for is DXGI. I said not found. Okay, looks like we haven't got it. Let me just have a look through. Oh, I get it. Right. My bad. That's why we need it to be a factory 1. Okay. Right. So we're looking through our adapters one at a time, and for each of those we can get a descriptor. We can get adapter descriptor. And we can go ahead and grab that. And what I'm going to do right now is I'm just going to return the OK message. So this function will run no matter what. And then what I'm going to do is tell my logger to print out that adapter. Okay, so I'm going to go over to my logger. I know there's a lot of back and forth at the moment, and I'm going to make another variant which will basically print out a description of an adapter. And this might complain. So just to cover my bases, I'll throw in some extra headers, DXGI and DXGI 1.6. And then I'll pop over to the logger. We can just right click and go to definition. And this is all the info that we have available to us. So there are really two things that I'm interested in. One is the description, so the name of the adapter, and then the other one is the dedicated video memory. So I'm going to make some code which will print all of that out. Now it's easy enough to print out this description because that's a wide character string, but then this dedicated video memory is a size type. So that's a little interesting. So what I'm going to do just to make things a little easier is I'm going to include a bunch of headers for handling strings, because it turns out we have wide strings as well. Anyway, but back to business. So of course we'll check whether we should actually be printing, and then we'll go ahead and print some stuff. Cool. So if we run this, we'll probably be expecting these lines within names of the devices. So I'll just go ahead. Yeah, I think that's fine. Gotta have a bit of faith. Just give it a run. Okay, we've got this stuff. We can close it down. And then if I open this up, this debug terminal, we've got 3 devices. So we've got Intel Arc graphics, we've got this RTX 4060, and we've got this Microsoft Basic Render, which I imagine is a software renderer. So the next thing I want to get is I want to get the memory of each of them. So in order to do this, I'm going to need to convert that memory amount into a string, and I'll do this with a string builder or string stream. So I'll have a standard wide string stream named builder, and I'm going to put this in, go dedicated VRAM, and then I'll go ahead and output that, and I'll be getting the builder string, but that's going to complain because it wants a literal, so I'll get the C string of that. And it turns out that although this function is a wide character, so it's gonna not like constant characters, it will handle it just fine if it's a wide string builder. Anyway, so let's give that another shot. Okay, what do we have here? So we've got the Arc graphics, and this is a little hard to read, but I guess that's about 1 gigabyte, maybe 1 and a bit. The RTX 4060 has about 8 gigabytes, I guess, of memory, and then the basic render driver has 0 VRAM. I imagine it's just emulated, so dynamically allocated. So what I'm going to do is I'm going to look through all of these. I'm going to select any which are hardware renderers which have the maximum amount of VRAM. So I'll pop back to my adapter selection, and now I'm going to start inspecting these things. Okay, so in order to determine whether something is hardware or not, I'll take the flags and check that against adapter flag 3. Please have it. Okay, so if I just go over, so I'm having a look here at the adapter descriptor 1. Have a look at the members. I'm really interested in this flags option. Here we go. So there's this DXGI adapter flag, and we got all of these ones, and it's the software flag. that I'm really interested in. So this is just taking, whoops, that shouldn't be or, it should be and, right? So we're just checking whether that specific bit of the flag has been set or not. And we want it to not be set. Then the next thing we want to know is whether this adapter supports DirectX 12. So what we can do is we can call D3D12 create device. Looks like we don't have it. So I believe that's in, I think that's in, let me have a go. There we go. Yeah, it's in that direct D3DX header that we downloaded from the GitHub. Cool. So we're going to have our adapter, and the way we do this is a COM pointer, but if we call get, that will get the underlying pointer, the raw pointer. The minimum feature level, so that is D3D, yeah, 12.0, I think. And then this is a trick here because we don't, another thing. So we're going to need there we go. Going to need the UID, universal ID of the object that we're creating. We're not really creating an object, but just to put something in, I'm going to put in the ID of the actual type, if that makes sense. And turns out that for the last bit, which is, what is it here? It's the pointer to pointer of device. If we put in nothing, then DirectX understands that we're not really creating the device, we're just querying whether the adapter could create the device. This returns a handle to a result, so we can then check if that succeeded and save that to another variable. Okay, and then there's one more check, and that is whether the dedicated VRAM is bigger than any other device we've seen so far. So we'll have I'll call it biggest so far. And then we'll check all of those conditions. Okay, so provided that is all fine, then we'll update our choice of adapter, and then we'll update our criteria. And now just to check, confirm which of these adapters we selected in the end, we can go ahead and log out the chosen adapter. Fingers crossed. Alrighty. No errors. That's good. We can close that down. Have a look. Yeah. Okay. And as we can see here, the selected adapter, I know this might be a little hard to see, but the selected adapter is that NVIDIA GeForce RTX 4060. Okay. Very cool. So, I got all these other random messages in here. So, I hope you enjoyed this session. A lot of it was just boilerplate, but this stuff is important, and hopefully future videos will get a little shorter. But anyway, all the best, and I will see you again soon. Bye. Hi, so I just wanted to take a second to say thank you to all of my channel supporters. If you would like to support the channel, it's $2.50 a month. That's all I ask. But it's not expected. If you are not able or willing to support the channel financially, the best thing you can do is the usual: like, comment, subscribe. Let me know what you'd like to see. Let me know what you're enjoying, because I am trying to make the best educational content that I can under the constraints. So with that out of the way, Really big thank you to Antonin Karet, Dankil Foles, Declan, Endelon Studios, Isaiah Meyer, Mathieu Derick, Moim, and Shreya. Thank you so much, my dudes. I really do appreciate it. It's fuel for the fire. Keep me going, keep me motivated. But yeah, have a great one, and I'll see you again soon. Bye.